Hi, everyone. How are you all doing tonight?
Right.
Good. Happy to hear it. So tonight I'm going to be talking about the power of definition management using ontologies and graph technology. I'm going to be discussing the one use case for graphs at Nearmap, which is about creating rules based on truths about livable world objects in graph format. Oh, thank you for reducing the glare. So this is going to create, the goal is to create a specialized knowledge base that's both human and machine readable. And so the primary themes are a combination of truth, rules, and graphs with a knowledge management lens. So what is Nearmap? Nearmap is an integrated geospatial intelligence company founded in Perth in 2007. We design and build our own camera systems for capturing aerial imagery in Australia, New Zealand, Canada, and the United States. We own a multi-petabyte and growing set of aerial image data. Our most recent AI version is Generation 5, Tranquil Pool. It includes 78 AI layers, which I refer to throughout this presentation as classes. So the process from AI layer to product begins with a definition. Once a class is defined, it goes to our expert labelers who manually annotate images using an in-house labeling tool. Labeling project results are reviewed and used to train our AI model for pixel-level object identification. Once trained, the model is evaluated for production readiness, and so properly communicating the definitions and instructions for each class is essential to making the whole system work. Nearmap has a lofty ambition, which is to be the source of truth that shapes our livable world. So there are two things to consider here. What is the truth, according to Nearmap, and what is a source of truth? Which brings me to the first theme, truth. As an AI ontologist, my knowledge base aims to capture definitions, which are factual descriptions of objects as they are in the world, as seen in aerial imagery. I want this knowledge base to be adopted as a source of truth for AI layer class names and meanings. And so, unfortunately, managing that growing petabyte-size image dataset is out of scope of tonight's conversation. We're talking about just the class names and their definitions. So I'd like to start. What is a Christmas tree? Anyone can shout it out. No takers? Okay, just as long as someone says a Christmas tree is a Christmas tree. I'm sure we've all seen data dictionaries that say that. So let's go through this. Is it something that's decorated? Is it a fir tree? Does it have to be a real tree? What about a palm tree with lights? Does anyone work in oil and gas? If you ask someone in the oil field, this is a Christmas tree. All of these are right, depending on your context. So, to understand what a truth is, a collective truth, you really have to think about what is the thing and what does it look like from above? Because all those pictures I showed you were either oblique or sort of eye level, but if you think about at scale, from a few thousand feet and above, it looks a little bit different. This is a Christmas tree farm, so it's a group of Christmas trees. So again, we need to know what kind of context and materials and exactly what we're looking for. From a philosophical perspective, this is the classic image from knowledge management. It's the goal, which is to make tacit knowledge explicit through documentation. In 1979, linguist Dr. Michael J. Reddy coined the conduit metaphor that I'll paraphrase. Words and symbols are containers for meaning. Communicating is basically where we abstract a combination of these implicit and explicit knowledges into a container, a word or symbol, for another to receive. So with all of this tacit knowledge running around, and also all this explicit knowledge everywhere, how can we align on the meaning of anything? So to determine what a collective truth is, you have to be aware of levels of abstraction in communication and ask questions to understand someone's perspective, like what is a Christmas tree? So here's another example. If I ask you all in this room, or this group of lovely stable diffusion generated people, what is a building? You might think of a simplified shape or symbol like the Monopoly piece here, or a particular building you've either worked in or walked by, like that round one at the top. So many of you might think of the simple learn to draw example, which is again the eye-level rectangle with windows and a roof. So the truth of buildings, according to Nearmap, includes multiple instances where there is no roof, and there may never be a roof. These are all from our imagery, and they are all considered buildings. The one during construction doesn't have a roof yet, the stadium technically doesn't have a roof, and this one after a damage event, which if you're carefully, you can see the roof has been torn off by tornado winds and is actually in the back of the image. Those are all buildings. So again, this is an instance where all the abstractions to the last slide are not wrong. But as we say at Nearmap, the truth is in the detail. It's the nuances of the definition that strengthen our models. Several external resources strictly define building as having a roof. However, these knowledge bases did not stand up to what our aerial imagery captures, which is the nuance, complexity, and beauty of the livable world. So I couldn't adopt external definitions or terminology for my knowledge base. And I had to be careful when defining rules between buildings and roofs. Which brings me to the next topic, rules. As you work through defining what something is, you have to think about what it is not, and how it differs from similar objects. This is the start of developing rules about classes. So there are two things to think about here. What rules can be written, and how to capture these rules. Class rules are captured at the object level, and the AI team uses these for pixel-level identification of classes. So again, what rules can be captured about an ever-changing world? The world does not stop and pose for our cameras. So animals in the first image are visible, but does this mean I need to make a rule about houses and birds or yard debris and birds? Probably not. This is a flood, so there's temporary water bodies. Water over a building has no roof. There's a boat inside the building. How can I create rules excluding buildings and boats if this is something we see in the world? The third image is a controlled burn. So the question here is that burned vegetation still technically vegetation or not? So with all of these edge cases, what rules can we actually document? Here's another quiz. Which one of these images have roof rusting? I'll let you all raise your hands. Who thinks A is roof rusting? Okay. Who thinks B is roof rusting? Okay, good. And who thinks C is roof rusting? Okay, you think all are all roof rusting. Okay. So the primary rule captured for roof rusting is that it can only occur on metal roofs. Example A is actually fallen leaf debris on a non-metal roof. Example B is a commercial roof. I think it's a modified bitumen roofing, but that rust is actually from the roof objects. So the rust is actually staining the roof, but it's not actually metal roof rusting. The third roof is the example of roof rusting. So everyone who raised their hand for C, congratulations. So this actually is a mistake that our labelers made, where they saw the first roof and were confused because they thought this pile of leaves are like, oh, is that rust? And so we were actually able to make this rule that says if it's not a metal roof, it can't be rust. So again, figured out some rules. How should I capture them? Traditional knowledge management loves to use documents. Wikis are one step to opening and making information accessible, but still primarily capture rules as text with some markup. And if you saw my DataEng talk at the conference, then that's where I talked about the whole thing of going from wikis to an ontology system, which I will not go into detail here, but the recording is online. So I want to capture definitions in a way that both humans and machines can understand. You can see this drive for can't talk right now. You can see this drive in the rules as code movement, if any of you are familiar with that. Sort of figuring out ways to make code that's written traditionally as text or documents, rules traditionally written as text or documents into code form. So, how can I organize and make accessible rules about livable world objects to both humans and machines? I really like this cartoon about an alien brain taking all of Earth's knowledge. It can do so because of its organization system. So Nearmap got past the first hurdle of trapped in documents by using a wiki. So this is a promising practice for many KM programs, but text rules in a wiki are still text. So the next step is to think about what a graph is. So a graph does not always mean a graph database. For this section, we're focused on the middle one, which is a semantic triple. A collection of semantic triples is an ontology. An ontology is a graph that is not a graph database. But an ontology, or a collection of triples, can be stored in a triple store, which is also known as a graph database. So it gets kind of like word soup there, so you really want to be careful if you're saying graph versus graph database. You want to clarify exactly what you're thinking about. So for us, for my topic, I'm really thinking about that semantic triple. The line graph, not really thinking about that in the graph database. That's kind of the icing on the cake. So how do you edit in Ontology? Protege is Stanford University's open source ontology tool. It uses W3 standards, including OWL and RDF, the standard schema, to compose ontologies. It provides a decent foundation for generating an ontology, but this hierarchy view is a bit limiting for viewing class relationships. It makes it look like a simple taxonomy, and you can't really see all the connections in their detail. So I wondered, with my custom annotations, versioning, and rule requirements, could I use a graphical ontology creation and visualization tool in Protege itself? Short answer, unfortunately, is no. As Protege is an open source tool, there are several open source plugins to support graphical ontology generation, such as the one shown here, which was developed partially by a gentleman named Pascal Hitzler, who works in Kansas. And he's actually my secret mentor, because we're both members of a very small Slack group that talks about ontologies. But unfortunately, the least negative thing I can say about this plugin is that it adds stuff to your OWL files, which if you're trying to use that in other parts of your ontology system, just gunks up all the works. So if you're going to create an ontology just in Protege, maybe try this plugin. But if you're going to use it in any other system, plugins just add stuff to your files. So my needs for graphical visualization, it can't scale. So this is something I still need to work on as a team, is how do we visualize the ontology for what different end users besides our web-based definition pages. So the value driver for developing content in graph format is I can't say that word tonight, is operationalizing for human and machine uses. So last year we prioritized integrating with our internal labeling tool to streamline our human labeler workflow. And so this year's and it's now accepted as a single source of truth, so check that box. What we're going to be working on this year is working with the data scientists to understand what their needs are to query and visualize the relationships. Also understand if we can automate any of those encoding rules for our data scientists, so that way we can kind of do that transformation from class level rule to what is it at the pixel level. I'd love to work with some reasoners to kind of see if I can discover new relationships and connections based on the existing relationships. And I created a set of 16 reusable relationships in the first round, but there is a lot more logic we can glean from this, and a lot more relationships we can find. And so working with our data scientists this year on what's valuable to them, and through all of these other steps, I'll be able to identify what other relationships would add value for our system. So, thank you, and I welcome your questions.
I will always work in the images. I work in the visible spectrum.
Did you say visible spectrum?
I work in the visible spectrum, just photographs.
Yes, we are all of our work is done on our own aerial imagery.
Why not use thermal imaging?
Use what, thermal?
Thermal imaging.
Our camera systems until now have not supported thermal imaging, so that's not something.
If you have thermal imaging, let's say early morning, of your programs to the gun.
That is something our computer vision folks are working on, so I'm sure there'll be something they can tell you about in a couple months, but I can't say anything else about that right now. But good point. Any other questions? If not, I'm going to go have pizza. No? Sorry.
I was going to say, I guess, what are ways to sort of like get started with, say, ontology, sort of general sort of data engineering senses? Because, like, say, at Nearmap, it makes sense that you would have, you know, this approach because I guess you're trying to classify, you know, everything that you can see in a map and having a structured way of classifying all these images and stuff like that. But do you see sort of like in a general business intelligence sense or something like that, the need for ontology in a broader data engineering use case?
I can see that, and there are upper level ontologies that try to just codify the meaning of the world. and sort of identify the different metadata concepts. And
So what is a user, what is a product?
Exactly.
Yeah.
And there's a lot of open source ontologies you can just search for, and that might be a good way to start if you're not sure where to go. Ironically, there's a pizza ontology that is used as kind of a learning ontology for people. There's also a chess ontology, which is the most intense ontology I've ever seen and don't understand it. Yeah. So I would start by just trying to find an example one, understand it, and see if that structure is useful.
What would be like, so you have Protege as like a tool that you can use. Is that like the best sort of beginner one? Like if you want to pick up a tool and just have a go at creating something and see if you could use it, is that a tool that you'd recommend starting with, or what's the entry point?
If you're starting with OWL and you want to start with RDF, sort of the W3C school of thought for ontology development, then Protege is your best option because it is open source, meaning it's free, and so you can just kind of plug in any existing ontology, quickly visualize it, and edit it. I mean, I don't want to sound sacrilegious, but you may not need Protege. It really depends on what kind of versioning you're trying to do, what kind of one big benefit of Protege is that it actually mints the URIs for every new class, and it really controls that in a really good way. But if you're just trying to test stuff out, I mean, you could even just try building it in a graph database, but I think Protege is the best.
And then you build it in Protege, like maybe a PC one or something, and then how do you go from there to a graph database? Do you just copy paste, or what's that?
If you talk to our friends at Neo4j, they have a process of how to port over the OWL files to their database.
Right. Just snuck the sales.
I did, sorry. I think, is there another question up here?
That's right. Still trying to figure out what ontology itself means.
Loud voice, mate, loud voice.
Sorry, I'm still trying to understand the simple terms of the meaning of ontology in an engineering context. How I use this concept in my work. I'm currently coming from a financial field. Like, what kind of use cases?
You should look at the finance ontology.
Finance?
There is a finance ontology. It was actually created by the people who wrote the book on ontology engineering. So.
What is, in simple terms, ontology?
It's okay. It's this, ontology is basically rules and logic about things. That is like this simple one, like rust is a condition of metal. Like it's that simple, like it sounds ridiculously simple, but that's just codifying that logic and then using it to understand your data.
See, like, what if, like, we wanted to identify, like, fraudulent, transactions or whatever?
Yeah.
Is it possible?
Yes, absolutely. There was some work done with the Panama Papers using graphs.
Oh.
Yeah, definitely look that up. I worked at Dun & Bradstreet, and they were actually that's when we did semantic metadata at that really, really high level to kind of understand businesses and what businesses existed. So yeah, this is a very different aspect of ontology. I actually haven't worked with images before. I'm mostly used to working with metadata. So this is actually really different for me as well.
It seems like it's got a relationship with, say, domain-driven design, like really how to,
Absolutely.
So you could almost say that, going on that tangent, that data mesh lends itself a little bit like there's a bit of a, having an ontological function within like a data mesh setup would make a lot of sense, wouldn't it? Because
it would.
Yeah, nice. Interesting. Any other questions?
Sure.
It's not related to data engineering, but have you found out any interesting insights with the way Nearmap has applied or done the mapping? Anything which you thought out of here?
So the most interesting thing was that sometimes the rules that I declare can't be applied because the way I say, a roof is not necessarily associated, it's associated with the building, but it's not a direct child. There are different rules that they have to use to formulate the model versus my rules about the world. And so by separating those two, we're able to kind of understand those different nuances. And so that's what we're going to be looking at is, can I take this rule and implement it across a class, or do we have to be a little more careful? Yes.
I had a quick question. Do you ever have to worry about the versions of ontologies, or like almost like schema mutation?
We have a 4-tiered versioning system that is described in our DataEng Bytes conference talk from last year. But yes, I actually had to go through my first, I gave a talk at 3 a.m. a couple of weeks ago for the EU, where I talked about how I got to go through our first variation, where there was a slightly semantic change that didn't quite break the data set. It's kind of like, did we need this much vigor in our versioning system? And it turned out that we did. Yes, versioning, yes. And that's actually one of the biggest lacking things of Protege, is that the versioning is, can't see the field here, but it's very manual. It's all manual in Protege, so that's why data engineers like yourselves be the ones to come up with superior versioning systems so that you can live as a system and not be reliant on this editor as a way to control the versions. One more.
We are mentioned manual, but at the same time, I remember you been referring to some artificial intelligence. How AI fits into the picture?
Sure, so these become the ground rules for our AI model.
Okay.
And so what we do is we identify objects using artificial intelligence from our images. And so these become the rules that then feed into the AI model that then goes over all of our petabytes of data and identifies objects in the imagery.
So sufficiently advanced set of business rules, essentially distinguishable from AI.
Yes.
Awesome. So maybe even ChatGPT is an application.
I've already been using it to try to write my definitions.
Oh wow.
I actually used it to come up with the title, so.
Well, round of applause. Thanks so much.